So in this video, I'm going to talk about isomers and two different types such as constitutional isomers and stereochemical isomers. And so isomers are different compounds with the same molecular formula. So different compounds with the same molecular formula. And so there are two ways that we'll talk about right now that can result in isomers. And so there is a type of isomer called a constitutional isomer. Constitutional isomer. And what that is it has different arrangements of atoms. Different arrangement of atoms. And so, for example, if you're given a molecular formula of C3H8O, you could have something like this. I'll do it in red. I remember the ends right here, they are designating CH3s. So you could draw that out. And then, so that's a constitutional isomer. And another way to draw it would be like this. And then one more way would be like this. And as you can see, they all have 3 carbons, 8 hydrogens, and 1 oxygen. And remember, at those points, there are 2 implied hydrogens. And so 1 implied hydrogen there, and that would be a CH3, CH3, and then 2 implied hydrogens there, and so on. I'm not going to draw the rest. And so let's do another one, another example of a constitutional isomer. So let's try C5H12. That's a 5. And so you could have something like this, or something like this, or even something like this. And so as you can see, they all have 5 carbons. You could count them out, and then they also have 12 hydrogens. And so now let's talk about the other type of isomer, stereochemical. Stereochemical isomers. So they have the same order but different arrangements. And so for now, I'm only going to talk about cis-trans, and later on we'll get into like R conformation, S conformation, and all of that stuff. And so if you have a double bond, and we know that double bonds can't rotate, so if you have a double bond, something like this, so that molecule is not the same as this one. And so this molecule up here would be cis, and this would be trans. And so essentially it's the same order but a different arrangement in space. So it differs in spatial arrangement. And so we call this cis because the two CH3s are on the same side of the double bond. This is trans because the two CH3s are on opposite side of the double bond. And so let's do some more examples. Let's say you have something like this. CH3, CH3. This molecule here, there would be no cis or trans because it has to be on different carbons, essentially. So you can't compare this CH3 to this hydrogen. And so no cis or trans. And same with a molecule that looks like this. CH3, CH3, and then bonded to a 5-carbon ring. And so this would have no cis or trans either, because it's a symmetrical molecule. And now, what happens if you have more carbons coming off of the double bonds? Well, there's a different way of naming those. It's really similar to the cis and trans, and we'll get more into it later, but just know for now, let's say we have that, CH3, and so this one, it would be called an E isomer, while this one, if these two switched, it would be a Z. So let me draw that. So this would be a Z isomer. But we'll get more into that in a future video. This is just for now to let you see that there are many different types of isomers, and a molecule with a molecular formula, as you can kind of figure out right now, if you have one molecular formula, you could have a bunch of different molecules that represent that molecular formula.